So, students, today we will discuss the biphenyls. We have already discussed the allenes and the spirens. In this compound is chiral due to stereoplane is present or chiral plane is present. Sorry, chiral axis is present, and due to the stereoaxis they becomes chiral. In this we have a tetrahedral molecule, and when this tetrahedral molecule gets elongated due to when you replace this carbon, it gets elongated. We have used we replaces with this carbon, then we will get the allenes. If you place, instead of this double bond, when you place the ring, okay, alkyl ring, when we placed instead of this double bond, okay, then it gets converted into spiral compounds. Okay, therefore in this case also there is elongation. Okay, if you put the carbon here, there is a tetrahedral, but it gets elongated. In this case it is also gets elongated. The biphenyls, when you in this case biphenyls, when we have two rings, and in this case A, B, C and D. Okay, these biphenyls, there is also elongation of, if you place the carbon, there is tetrahedral gets elongated. Okay, if you, okay, there is elongation of tetrahedral geometry. Such type of compounds we have discussed have the axis of chirality or stereoaxis. In these compounds, by interchanging these two groups, one compound or one isomer can be converted into another isomer. So, okay, you can interchange these two groups, it gets converted into another isomer. Such type of compounds can be explained their chirality on the basis of stereoaxis, biphenyls, allenes and spirals. Amongst these, we have studied or learned the allenes and the spirals. Now we will discuss the biphenyls. In biphenyls compounds, there are two benzene ring is there, phenyl ring is there, and at the ortho position there is a groups or substituent is present, and due to these ortho substituents, crowding is increases, and that's why if these two rings, if it is planar one, but due to these two ortho position groups, your to avoid this crowding, your first ring gets horizontal position and is vertical. Okay, these two rings is looking like that. The first ring is the planar one and second is the like that. Therefore, the C is away from the observer and A is towards the observer, and these two groups are in a plane. Okay, like that. If your ring, if present in such, okay, first that ring is at present at the planar one, and second ring is present, okay, Okay, the second ring is horizontally placed. Okay, like that. Okay, first is like that and second is the like that. Why such why not these two rings becomes planar? Because it avoids the its ortho repulsion. Because if it is gets planar, okay, if suppose these two rings is planar one, then there is a lot of steric strain is produced, and to avoid this, one ring gets these two rings are perpendicular to each other. Okay, the condition for chirality in biphenyls is as like our allenes. Okay, we have seen that if allenes, if the like that situation is there in allenes, okay, three groups are the same, then this molecule is not optically active. This molecule is not optical active molecule, because when you pass the plane, this within AB it gets divided into two equal parts. Okay, we have studied that if plane of symmetry is passed through the molecule and it divides to equal parts, then this molecule is not a optically active. But suppose when you replaces the B groups, then the condition for the alane is that it should have the two different groups attached to each corner. Okay, such condition is also valid for these biphenyls if the groups is attached is a biphenyl ring is same. Okay, if suppose these are one of the compound of biphenyls, first is looking like that and other is looking like that. Okay, if suppose we pass, okay, this is the this benzene ring or phenyl ring is horizontally placed, and therefore when we pass the plane is passed through this benzene ring and pass through this. Okay, if plane is passed through this molecule, okay, therefore from this benzene, this all the benzene is the planar one and it comes under this plane, but this is divided into two equal halves. Therefore this molecule is not optically active. Therefore the condition is your phenyl ring should have the different group attached. Then your biphenyl is the biphenyl compounds are optically active. Now due to the ortho repulsion, it's one of the ring is gets horizontal and one gets the vertical. We have one example is there, diphenic acid. This is one of the compound of biphenyls, and to resolve its enantiomers is difficult. To resolve enantiomers means what? If suppose A and A star is enantiomers to each other, and if we try to remove A, not we want A star, but these two compounds are the same one, but its orientation or these two compounds are not these are the superimposable and enantiomers, and when you try to remove it is possible when their energy difference between these two compounds is higher and not one enantiomer is continuously convert to the other enantiomer. Okay, some energy is required. If energy is required high for the conversion of one enantiomer to the other, then its A can be removed from our mixture. But if there is continuous energy difference between those two, to convert first enantiomer to other enantiomer is very less, then it's continuously convert one enantiomer to the other. Okay, there is a continuous equilibrium is there. Therefore, when we try to resolve it, it is impossible to resolve, because when you try to remove this, it gets converted into A star, because there is a continuous conversion of A into A star is there. Okay, therefore, why there is continuous conversion is possible? Because energy barriers or racemization. Okay, this condition is racemization. One is converted to other. Racemization energy barriers is less, then it gets A star is converted into A is converted into A star is continuously converted into A. Continuously equilibrium is there, and therefore such condition it is to remove or resolve A from A star the mixture is difficult. But if the inner resolution racemization barrier energy is higher, then A is not easily converted to A star, and therefore it is to remove A from mixture, from racemic mixture is easy. Okay. The diphenic acid, one of the diphenyl compound, it is difficult to resolve. It is difficult to resolve means what? First enantiomer is not separate from the other, because there is continuous exchange of first enantiomer to the other enantiomers is there. Okay. Our first ring is the vertical one and second is the horizontal one. Okay, like that, horizontal one. And this is our diphenic compound. This is our diphenic compounds, and the diphenic compound shows the optical activity, but to resolve it, it is difficult. When this first isomers, if supposed to convert to the other enantiomers, okay, this its enantiomer is looking like that. Okay, that is the first isomers, and its enantiomers is looking like that. Okay, this is the first enantiomers, and these two are the enantiomers to each other, non-superimposable mirror images. But when there is a conversion of this enantiomer into other enantiomers, takes place. This change takes place via the flipping of this, this slipping of this benzene ring. This will slowly slip and gets another isomer. Firstly, it gets planar one. Okay, therefore, conversion of first enantiomer to the other enantiomer takes place via the planar. Okay, these two rings becomes planar, and then first enantiomers gets converted into other enantiomer. Therefore, its intermediate step is like that. Okay, it gets this ring gets somehow planar one to this. Okay, these two rings becomes the planar after that. Okay, it becomes planar. During this, your ortho. Okay, there is some bending of ortho position groups takes place, and then again it gets converted into other flip of this in horizontal, and we will get the other isomers. Okay, and if and these both enantiomers gets converted to each other via this planar step, and if the energy barriers is less in between these two, in between these three, then it first easily gets converted to other enantiomers because it is require less energy because there is a less, this group is the small group. Okay, therefore there is a binding which takes place easily, and when one enantiomer gets converted into other enantiomer easily. Okay, therefore this molecule there is continuously flipping from such to such is happened there, and therefore it is not easy to resolve one of the enantiomer from this compound, but it shows the optical activity, but its planar form it's not optically active because it shows the center of symmetry or inversion. It shows the inversion. Its planar form is not chiral active because it has the center of symmetry. Okay, therefore this if he replaces that hydrogen from the fluorine, okay, instead of hydrogen we have the fluorine instead. Okay, this compound fluorine is also very small size. Okay, therefore the energy required for the racemization, that for the racemization means what? First is converted to the other easily convert to each other. In this case also there is easily conversion of one enantiomer to other enantiomer is possible, and therefore this compound is also not resolvable when we replace the hydrogen by fluorine. Okay, therefore this compound is also not resolvable. Now we have one example, that is diamide. Diamide is one of the example. One of the example. Its structure is like that, and this compound is easily resolvable. This compound is easily resolvable because at the ortho position there is a bulkier group is there, and when first isomer is try to convert to the other isomer, then your ring, this ring gets planar first, and due to that planarity there is a bending of these groups is there, but it's highly strained situation. Therefore in this case the energy of racemization barriers is the higher, and therefore first isomer is not easily converted into other isomers via planar intermediate. Okay, in this case one enantiomer is converted into other enantiomer via your transition is planar, and then you obtain the other enantiomers. But due to it, both these groups are the very bulkier, and therefore in this case there is not easy conversion of first enantiomers into other enantiomer is not possible or very difficult. Energy required is high. Therefore the resolution of the first enantiomers from the other enantiomers is easily can be done for this molecule. Okay, when the hydrolysis of this compound is carried out, you will obtain such type of compound. Okay, hydrolysis means one of the this hydrogen water is replaced, and you obtain the lactam NCO. Such type of lactam is obtained. Okay, we have obtained the lactam. You obtain lactam, and this lactam obtained is not optically active because it is having the center of inversion or center of symmetry or inversion, Therefore, after the removing of H2O from this molecule, you will obtain the lactam type of compound. Lactam functionality, this NHCO is a lactam functionality and it's planar one. Okay, due to this ring is formed, therefore molecule will take all these things, rings becomes in a plane, and therefore a plane is passed, and therefore it is an optically inactive molecule. About this molecule. Okay, now we have buttressing, one of the effect, that is a buttressing effect. If we have the compound like that, there, and in this compound at the meta position there is a substituent is there, and when first enantiomer is converted into other enantiomer, we have known that it's is passed from one enantiomer to the other enantiomer via planar state. When it gets planar, okay, if we try to convert to other enantiomer, therefore it firstly takes planar form, as we know that when such planar form takes place, this ortho groups somehow gets, okay, this ortho group somehow gets bending takes place. But at near to this there is NO2 is there, and therefore the bending of this molecule is difficult, and therefore conversion of one enantiomer to the other enantiomer is difficult, because it should require the higher energy, and that is the racemization energy barriers increases. Racemization energy barrier increases means that molecule is not converted other enantiomer via this planar state, because this planar state often is very strain state, and therefore from this conversion of one enantiomer to the other enantiomer is very difficult. And why this is difficult? Because our NO2 group is at meta position, and therefore due to this that molecule is not easily, okay, instead of NO2 there, if there is hydrogen one, okay, and therefore its enantiomer is difficult to convert one another to other compounds. And if one compound is like that and other, if suppose compound is like that, okay, that NO2 group is at fifth position, 1 2 3 4 5. Fifth position is NO2, though it is meta, but for this it is meta, NO2 is meta to this OME. And when we compare these two molecules, the energy of racemization is required for the first molecule is higher than the second molecule, because such type of planar form or first enantiomer is not converted to other enantiomer due to there is a crowding is there. Okay, that's why this molecule 3NO2 molecule is highly not racemized, and while 5, if NO2 is at 5 position, it gets easily racemized. One molecule is converted into other enantiomer, easily takes place. Now we have the some other examples of biphenyl compounds where there is a cyclic compound is there. Okay, that is bridged biphenyls. That is the bridged biphenyls. Okay, if suppose our biphenyls is like that, and CH2N, if CH2N and second one is our another compound, okay, where if N is the twice time, and third compound we have also. Okay, that is a bridge compound. Okay, one of these are the bridge compounds. If you consider the first compound, the ring is small side. Okay, if n is equal to 1, that ring is the small size. Therefore, these two rings becomes planar because highly strain is produced. If second ring gets horizontal planar, because why our biphenyl rings optical activity is produced, because the second ring is gets somehow first is the planar or vertical planar and second is the horizontally planar one. That's why but in this case that is the planar one and it's divided two equal halves molecule. Therefore it's not a optically active, this is optically inactive molecule. This molecule when you pass the plane, it gets, if it is planar, it gets not optically active. But this molecule, this ring is enough big, therefore it gets somehow, there is a first, say one of the ring gets somehow tilted, somehow there is a first and second is the gets perpendicular to each other due to this ring size is bigger than this. And such of condition is obtained when you have these two groups, ortho group should be bulkier one, then and then this small, then and then if it is not bulkier, then it gets planar and not shows the optical activity. But if these are the bulkier one, then this molecule, this second ring gets horizontally planar and therefore it gets optically active. For this molecule, it's the ring is the big side ring is there, and this due to zigzag motion, okay, that zigzag arrangement is that the big size ring achieve the zigzag ring, and therefore the strain is produced, is removed by this zigzag rings, and therefore this is also okay. If it is bulkier group, this becomes the optically, this group, this compound becomes the actively optically active one, and racemization due to angle strain, due to steric interaction, racemization also difficult for this molecule, and it easily gets optically active one. And these are the bridged biphenyls. Okay, some compounds. Okay, then one of the type is the okay 2,2. This compound is 2,2 biphenyls. Okay, these are the 2,2 binaphthalene, binaphthal compound is there. Okay, 2,2 binaphthal. Okay, these are the 2,2 binaphthal compound is there. 2 naphthalene, naphthalene is there. Okay, naphthalene is just looking like that. Okay, OH is there, and this OH other to this OH other naphthalene is attached, then you will get the BNAP. It is also called as the BNAP. Okay, BNAP H. First isomers is, if suppose it is the first isomer, its enantiomer is looking like that. Its second enantiomers, and first ring if it is like that and second ring is like that. Okay, first ring, this ring is looking like that, and other ring, okay, and the other ring is first if it is planar one, then the second one is like that. Okay, so it is perpendicular to each other. Okay, first ring is gets perpendicular to the like that rings is there, because this hydrogen is again there is repulsion, and this is towards us. Okay, this if you take move towards us, it's towards us. This OH will becomes away from us, okay, when you towards us, and this is also towards us. This is also towards us, and this is also towards us. Okay, like that these two groups are towards us, and this if it is like that, okay, and this is okay like that, and it's avoid the its steric interaction. Okay, like that it avoids the steric interaction. This hydrogen is avoid, this ring is away, this ring is away like that. Okay, if it is like that and it is also like that, but this is towards us and this is this towards us. Okay, if second is towards us, in this case second is away from us, and due to that this ring is away towards us, the OH is towards ourselves. Okay, like that. If first is like that and second is also attached to is like that. Okay, like that situation is there. Okay, like that situation is there. Okay, first ring and the second ring, first that benzene ring, if okay, suppose like that first this is towards ourselves and the OH is attached is away, and second ring that is away towards, and therefore the hydrogens of these two rings is away from each other, and therefore there is a steric interaction is minimized, and this is the another chiral reagent. This is one of the chiral reagents. 2,2-binaphthol, or it is also called as binap. It's one of the important chiral reagent in asymmetry synthesis. This is all about the biphenyls, and it is also called as the isomerism. We call that compound because there is a restricted rotation in single bonds. Okay, those enantiomer is produces or isomer is produces due to restricted rotation of the single bonds. That isomer is called as the atrop isomers. Okay, therefore the biphenyl compounds are the atrop isomers. Okay, if sometimes you ask what is the atrop isomers, then you have to discuss about the biphenyl compounds. This is all about the biphenyls. Thank you very much.